So basically, Bilinear transformation is used to avoid the drawback in the impulse invariant. Where what is the impulse invariant problem? For high frequencies above this primary string, we can't design. So it is limited to the low pass filters and band pass filters. Okay. Therefore, we go for the Bilinear transformation to overcome that problem. So many poles to one pole mapping should be avoided through the Bilinear transformation, right? So for this, I will take the first conversion, a transformation. For that, I will assume the analog filter transfer function h of s is equal to b by s plus a. So say this is my transformation. Don't feel that it is looking simple, but it will be applicable for all also. So it's just that's why for transformation derivation, I have taken a simple format b by s plus a. So this h of s is nothing but output by input. So output, if I say y of s and input is x of s, this can be written as b by s plus a. Then I will take cross multiplication. Therefore, y of s into s plus a, then b into x of s. Then I will multiply this. It will become s into y of s plus a into y of s. This is equal to b into x of s. This s into y of s is nothing but it is in time domain. Just take inverse Laplace transform on both sides. So what do you get if you take inverse Laplace transform on both sides? S into y of s. How can I write? Sirisha, what is the inverse Laplace transform of s into y of s? S into y of s is transformed to d by dt of y of t. Okay, then y of s, a is a constant. So y of s is transformed to y of t. X of s is transformed to x of t. Right? Now, if I place this there, I can write it as d by dt of y of t plus a into y of t, that is equal to b into x of t. Okay, then this d by dt of y of t, I can write simply like y dash of t. We used to basically denote it just for simplicity. B into x of t I have written. Then see, after getting this y of t, what we need to do? We need to convert it to discrete domain. So we need to write t is equal to nt. This equation can be written as y dash of nt plus a into y of nt is equal to b into x of nt. Okay, then this y of t basically say say this is equation 1. I'll come back to this point. From or by the trapezoidal approximation, trapezoidal approximation. I think in the numerical methods you might have studied this. If it is not learned, please note down this point. By the trapezoidal approximation at t is equal to nt. Sorry, first I'll write this. Then I will substitute t is equal to nt. For that, by the trapezoidal approximation, basically the y of t, any function, uh, any continuous function can be written as within the limits t naught to t y dash of tau d tau plus y of t naught. So it is the summation of all the points of derivative terms including its initial value. So that is y of t. That means when you start at 1, the next difference is 0.5. If I say this is the point I will get. Next difference I will mention 0.1. Next difference I will mention 0.2. Then what is this value? This initial value plus all the derivative points, sum of all the derivative points, right? So this is the point. Sum of all derivative points plus its initial value. This will give you the total value at any point. Yes, Sandhya, are you getting? Sirisha,
Yes, sir.
any doubts so far?
No, sir.
Yeah. So this trapezoidal approximation, uh, we can substitute in the first equation, but the first equation is having a t is equal to nt. So for this also, a t is equal to nt. If you substitute, this will become y of nt is equal to, this integral won't come in the discrete. If you take samples, this integration will go to like a summation, but here it is y dash of tau. So we will take it within the limits, the summation of this y dash of tau. That is the average t by t into y dash of nt plus y dash of nt minus t. Because we are taking the present value and past value difference, we are taking the difference. We need to take both. We need to take both and take the average, the t by t. This is the y of nt, y of nt from this, including the initial value. Initial value is coming from y of nt minus t, the past value. Okay. Now, this trapezoidal approximation, I will substitute in the first equation. Or from for the first equation, I can substitute here. This is good. Therefore, nt, I will substitute the first equation in the second equation. Say I'll say this is second equation. This is second equation. So I'll substitute say first equation in second equation. Substitute equation 1 in equation 2. Therefore, equation 2 can be written as y of nt is equal to t by 2 into this y dash of nt is from the first equation. Y dash of nt is equal to y dash of nt plus a into y, y of nt is equal to b into x of nt, right? This is the first equation. From this, y dash of nt is equal to minus a into y of nt plus b into x of nt, right? This I will substitute here. It is a into y of nt plus b into x of nt. Next, y dash of nt minus t. So same thing, but y in place of y dash inside nt minus t you should write, plus b into x of nt minus t. And next, yeah, bracket close, then y of nt minus t, bracket close, plus y of nt minus t. That means minus a y dash of nt minus t plus b into x of nt minus t. Done. Now we will simplify this. This is nt. This is not dash. This is not dash. Okay, this is y of nt minus t only. It's not dash. So it's not dash. Y of nt minus t only we should write. It is for y dash of nt only. So we'll simplify this. Any y of n t minus t here is there, but we can not cancel it. Okay. Then what we do is we will just gather y of n t terms one side and y of n t minus t one side, another side. Then this side y of n t is there, and this side y of n t here. So we'll take it to this side. So it is minus, it will go to plus here. So a into t by 2 into y of nt y of nt y of nt minus, sorry, y of nt only, y of nt, that's it. Is equal to then y of n minus nt minus t, here one term, here one term, therefore two terms are there. First I will write a positive term, I mean this coefficient. Then next is this coefficient, that is minus at by 2 into y of nt minus t. Okay. And if you want to make it this all y's to this side, then make it this also to the left side. Anyhow, we want again y of z by x of z. So let us make this y of all y terms also to the left side. Then is equal to all x terms to the left side, right side you keep it. The first term is x of nt, only one term is there, that too with the coefficient bt by 2, x of nt. And second term is x of nt minus t with the coefficient b again. So again this is same coefficient bt by 2 only. So it is x of nt minus t. Okay. Right. Now we have this total equation in discrete domain. Now take the jet transform. Take jet transform on both sides. Therefore, what do you get here? Y of nt is written as y of z. Then of course you can take common, no, here also y of nt. So I can make it like y of z into 1 plus at by 2. Okay. Then here for this I will take it as 1 minus at by 2 into y of nt minus t. It is like a shifted version. So one time shifting. So z power minus 1 you will get. This is capital Y of z. This is equal to bt by 2 into this is x of z. This is plus one time shifted. So z inverse into capital X of z. Okay. Understood this step conversion, z transform, Sandhya? Okay. See, now I will take common y of z because I want a y of z by x of z. So I will take common y of z. Y of z I will take common from left side. Then it will be like 1 plus at by 2 uh, plus sorry, it's not plus, minus 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 1 minus at by 2 into z inverse is equal to this side. If we take x of z common, we have bt by 2 bt by 2 bt by 2 into 1 plus z inverse. Correct. Now what I want is y of z by x of z. This is the h of z. That's why I'm taking this. This is equal to, now x of z is equal to bt by 2 into 1 plus z inverse divided by this whole 1 plus at by 2 minus 1 minus at by 2 into z power minus 1. Okay, this is equal to Now I can take, I can again simplify this. 80 by 2, I can take it common. So I can simplify it further. It is 1 plus z inverse, denominator 1.
Sir, the jet inverse is whole for 1 minus 80 by 2, no, sir?
Correct. That's what I'm feeling. Why minus 1 plus 1 is cancelling. Okay, this is just inverse for whole. Right. Now Sandhya, correct. Then this 1 minus z inverse, 1 minus z inverse, we can write. Then plus 80 by 2 plus 80 by 2. So 80 by 2 into 1 plus z inverse, I can write. So this plus this. I can't take it common, but I can, I will take 1 plus z inverse common. So that numerator, it will be cancelled. Therefore, it can be written as bt by 2 into 1 plus z inverse divided by, here I will take 1 minus z inverse by 1 plus z inverse plus 80 by 2. Therefore, 80 by 4, yes. That whole into 1 plus z inverse. Then this and this is cancelled. Therefore, h of z, this is h of z. This is equal to bt by 2 divided by, here also tt not cancel. This is out of the range. Okay, bt by 2 into at by 2 plus 1 minus z inverse by 1 plus z inverse. Then t by 2 you can take common. Now t by 2 you can cancel it. So bt by 2 divided by t by 2 we will take common. So it will be written like a plus 1 minus z inverse by 1 plus z inverse into 2 by t we should write here to cancel it. So this is cancelled. Then it's looking like b by this, 2 by t into 1 minus z inverse by 1 plus z inverse plus a. Got it, Sandhya? This is the final transfer function h object. Any observation here? Here h of s taken is b by s plus a. Then what we got after transformation? H of z is equal to b by 2 by t into 1 minus z inverse by 1 plus z inverse plus a. Right? Then both are similar. That means the transformation is s. In place of s, we have to keep this 2 by t into 1 minus z inverse by 1 plus z inverse. This is the transformation. Okay. So wherever you have the s in the analog filter, you just have to keep this t by 2 into 1 minus z inverse by 1 plus z inverse. This is the transformation, bilinear transformation.